everyone! Ngayon ay magtatakal tayo about magnetic fields produced by currents. Okay, first is, my name is John Daniel Sison and here are my group mates. Jerome Ancheta, Caraan, Joenel Colmo, Vinz Coruña, Mark Joseph Dalman, Jesriel Erejer, Orate, Ricardo Sabinorio, and lastly, Achilles Villalobos. Today, here's the overview and we're gonna tackle about magnetic force. Second one is magnetic fields, and under that, there are sketching and interpreting magnetic field patterns. Second one is the currents, and letter C, magnetic field caused by a current, and under that is the Ampere's law. Second is electrical current through a wire, determining magnetic field direction, at itutulong dito yung right hand rule, and for a straight wire, a loop wire, and solenoid wire. Next is the application of magnetic fields and problem solving, which is may tatlong problem solving doon. And lastly is the summary and main points.
Hey everyone, today we are going to explore an amazing hidden superpowers that's all around us. It is invisible yet powerful and can do many things too. Are you ready to become a magnet detective? If yes, let's go! Before we dive in, did you know that there are 4 fundamental forces in the universe? These forces hold things together and make things work the way they do. Out of these 4, there is one fascinating force, and it's called electromagnetism. Raise your hand if you ever play magnets before. That's great. Now, can anyone tell me what's special about magnets? That's right, it can attract or repel objects, or certain objects. Well, today, we are going to dive into the world of magnetic force and magnetic fields, which is the key components of electromagnetism. Imagine being able to control objects without even touching them. That's the power of magnets, right? But have you ever wondered what causes this mysterious force? We will discover how magnet works, the invisible force field that they create, and how this manage will help us in our daily lives. So get ready to unlock the secret of magnetic world, and be prepared to be amazed with things that surround us. And be prepared to be amazed by hidden forces that surround us. Let's start our magnetic adventures. Hi everyone, this is lecturer Jerome, and now we will discuss magnetic force. Magnetic force is a force that is generated by the motion of electric charges or magnetic fields. It is fundamental force of nature that is responsible for the interaction between magnets, electric currents, and charged particles. Kung matatandaan nyo sa unang topic natin, di ba ang tinapik natin is yung static electricity. Ngayon naman, ang topic natin dito is current electricity or yung movement ng electrons. There is a movement of electrons na dito, which is yung mga electrically charged particles. Ngayon, dun sa static electricity, it is a point charge at rest. Ngayon, in magnetic force, 2 magnets can either snap together or push each other apart due to magnetic force. So, magnetic force ang tawag natin doon. Just like our understanding that the same charge will repel and the opposite charge will attract. So, magnetic force is syempre vector quantity din siya, meaning it has both magnitudes and direction. At kung ano ang direction ng force natin, yun din syempre yung direction ng magnetic field natin. And the direction of electric charge or current. Ngayon, in magnetic force, it is a force of attraction and repulsion that arises between electrically charged particles due to their motion. Sinabi ko nga kanina kung ano yung topic natin ngayon is about current electricity, which is there is a motion involved here, while static electricity basically means statics at rest, or at rest lang siya, walang movement. So, magnetic force can also describe as the force exerted upon charges caused by the magnetic fields created by the other. This force causes the magnets to attract or repel another. If you can see from the diagram, we have A, B, C, D. And A and B, what do you think is the forces that acts on them? If you try to see the arrow symbolizes the direction, di ba? So, kung makikita natin, they are pointing away to each other, yung A and B natin. They are pointing due to the fact that we close or didikit natin yung same poles natin. Let me ask you. You can pause a video and answer my question. What is the two end poles of magnetic bar? That's right. We have the north and south pole. In magnets, we have two poles. North poles represented by N, south poles represented by S. Ngayon, pinagdikit natin sa A yung north and north. Anong mangyayari? They will repel to each other. When you bring the north pole of one magnet close to the south pole of another magnet, the forces act between them is... That's right. We have attractive force. Yung south to south, anong mangyayari? They will repel to each other. Unlike dun sa C and D, we close or pinagtabi natin yung different poles, yung opposite poles, yung south, pinagtabi natin sa north. What do you think will happen? They will gonna have the attractive forces. Katulad din sa D natin, north and south, they have the attractive forces. So as I said earlier, magnets always have a south and a north pole. Like poles, south to south, north to north, they will repel. And unlike poles, they will attract. Ayan. This is the basic principle of pole law. Next natin, to understand magnetic force, we must also understand magnetic field. What is magnetic field? When two magnets are near each other, their field lines interact, resulting in an attraction or repulsion. Just like our current understanding of electric field, they behave the same as the magnetic fields. There is the involvement of line here. Ngayon, kung babalikan natin, di ba meron tayong south, north, poles, ang direction natin, dun sa may magnetic lines natin, may arrow-arrow tayo dun, di ba? The arrow will always start from north going to south. Yan yung lagi nating tatandaan. So, kasama yan sa sketching and interpreting magnetic field pattern. In sketching and interpreting magnetic field patterns is like creating a map of a magnetic force field. So, we are making map that shows force flows around a magnet. Using iron fillings dyan, tingnan nyo yung diagram natin. As you can see, they filled iron fillings there to the top of the board. And in that way, magpo-form tayo ng parang ganun sa may second picture natin, yung mga curvature line. Then, the lines are thicker near the magnet's ends where the force is stronger. So, it means that on North Pole and on South Pole part, there is a stronger magnetic field. Yun yung tatandaan natin or yung pinaka-keynotes natin dito sa magnetic force and magnetic field lines. Next is, field lines never cross or they never interact and their density indicates magnetic field strength. Tignan nyo yung unang figure dyan. We have one curve, di ba? So, it means we only have one tangent line. Unlike dun sa pangalawa, meron tayong tangent line. Tangent line indicates the direction of the force. Hindi pwede na magkaroon tayo ng dalawang direction sa iisang point ng magnetic or the point charge natin or yung charge natin. Hindi pwede the magnetic force at the same point, which is not possible if we have two lines in field lines na nag-intersect. Kapag kasi nag-intersect sila, magkakaroon tayo ng two direction, which is not possible. Yun yung key points doon. So, as I said earlier, the density of field lines indicates the strength of the magnetic fields. Mas madaming field lines, mas strong yung magnetic fields. Mas konting field lines, mas weak yung magnetic fields compare sa mas madaming lines. So, field lines always form closed loops starting and ending at opposite pole. From north to south. Laging from north to south yan yung arrow natin. In understanding field patterns, it will help us to visualize the magnetic force because magnetic force is unseen. Hindi natin siya nakikita in our naked eye. So, in that way of building or understanding magnetic field, we understand the magnetic force, the strength, and its direction. So, next, let's go to the current. So, what is current? Current are the rate at which electrons flow past a point in a complete electrical circuit. The common symbol for current is the upper letter I. So, what do you think the symbol for the ampere? That's right. This is the uppercase letter I or the capital I. So, mahirap siya, no? Mahirap siyang i-understand at first sight. So, in order for us to understand, we must build analogy in that concept. Kung makikita nyo dun sa diagram natin, there is a flow of electrons. And the equation for this, since we are dealing with physics and we need the mathematical equation in concept, current is equal to the change in charge over change in time. Always remember that use coulombs in charge and use seconds in time. So, sa analogy natin, imagine a line of people getting into park. So, pupunta sila ng park. The people represented as the electrons. Electrons natin yung mga tao. And yung line natin is yun yung nagre-represent ng wire natin. So, the current is like the number of people passing through the gate of the theme park per second. So, if 60 people, which is the charge, go through the gate in 120 seconds, which is ng time natin, the current would be 0.5 people per second. This means that 0.5 people, which is the electrons, are passing through the gate, flowing through the wire every second or in a certain amount of time. In this analogy, the formula for current helps us find out how many people electrons or the electrons are passing through the gate, flowing through the gate per second or a certain amount of time. So, we have two type of currents, which is the direct current and alternating current. Ang pinaka-basic idea lang naman dito is direct current flows in one direction, as you can see on the first table or in the first illustration, while the AC or alternating current flows back and forth like a swinging pendulum. So, yun, back and forth. Yun yung pinaka-main idea natin dito sa two types of current natin. Direct current is used in batteries and electronic circuits, and the AC or alternating currents is used to power the house, business, and other buildings. The type of current flows in one direction only, like water flowing through a hose. It is often used in things like batteries and electronic circuits. So that's right. We have two types of currents, alternating and direct currents. Remember that direct currents is one direction only, while the alternating currents is like the swimming pendulum. A magnetic field caused by a current. A magnetic field is produced whenever an electric charge is in motion. As you can see, we have wire in the video. And spinning and orbiting of the nucleus of an atom produces a magnetic field, and as thus electrical current flowing through a wire. As moves through a power line, it creates a magnetic field called electromagnetic field. The strength of EMF is proportional to the amount of electrical current passing through the power line and decrease as you move farther away. Kung makikita natin dun sa video, merong mga electrons flowing in that wire. Tapos nag-field tayo ng feelings dun, or yung tinatawag natin na iron filings. So, kapag nailagay niya iron filings doon, tignan nyo, magpo-form siya ng circular pattern. Yung circular pattern na yan is what we call our magnetic field. So, magnetic field is caused by the current as long as there is a movement or a motion of electrical charge. Yun lang yung pinaka-main idea sa part na to. And next.
Hi everyone! So, we're talking about Ampere's Law. So, ano nga ba yung Ampere's Law? Ang Ampere's Law ay natuklasan ni André-Marie Ampere. Isa siyang French physicist at mathematician. Paano niyang discover ito? Sa paraan ng pagtuturo, biglaan niyang nakita sa kanyang compass na nakalagay sa tabi ng isang current. Binuksan niya yung current at nakita niyang gumalaw yung compass. Bakit gumalaw? Ang Ampere's Law ay sinasabi na when we flow currents through a wire, it generates a magnetic field. Galing, di ba? Yung magnetic field na to is nakaka-apekto siya sa kanyang surrounding areas. So, balikan natin ano nga ba yung meron sa magnetic fields. So, tulad sinabi, magnetic field from the word magnets, electromagnetism. Meron siyang attract and push effect, di ba? So, sa Ampere's Law, sinasabi na kapag ang isang wire, yung wire na to, syempre, gawa siya sa known as ferromagnetic materials. Ngayon, ang ferromagnetic materials is basically like copper, iron, metals, something that can induce electric or can flow electricity in them. No? Basically, kapag nilagyan mo ng electric current ang isang, let's say, copper wire, magkakaroon siya ng magnetic field dun sa around ng wire. So, nag-generate siya. Ang galing, di ba? Yung generated natin na magnetic field, paano nga ba natin malalaman kung saan yung direksyon ng pagdalo nila? Doon natin papasok ang right-hand rule. Itong sum natin, ituturo natin siya kung saan ang direction ng current. Let's say ang current natin is from right to left. Itong kamay na to, itong palm, ang ating gagamitin as normal force. Since ang current natin going to the left, pa-fold lang natin ang ating fingers, makikita na natin ang direction ng magnetic field. Yung magnetic field na to, makikita natin as the current going from right to left, the magnetic field circulates going from outside, going back in. Basically, pag ganito ang daloy ng magnetic field. Okay? Imagine niyo may wire pa din dito ha. Wire, ito yung magnetic field. Since papunta siya dito, right hand rule, iikot siya, ganun. Ganito ang ikot ng ating magnetic field ngayon. Ampere's law and the equation, so what is it nga ba? So Ampere's law, we say that the sum of the magnetic field times the circumference is equal to the permeability times the current. Since ang hinahanap lang natin is yung magnetic field, kailangan natin iiwan si B sa one side. So paano natin nga ba gagawin yun? Siyempre, we just divide both sides by the change of L, which is the sum of change of L is the 2 pi r or the circumference of the circle. So bakit nga 2 pi r? Kasi sa ating current, sabi natin, meron tayong magnetic field na nagsasurround sa isang current. So dun pa lang, masasabi na natin sa word na surrounding or around the current, meron siyang napo-form na circle. So the circular motion around the current is the magnetic field, which is yung sabi natin kanina, is the direction of na ginagamit natin sa right hand rule. Okay, so yung 2 pi r na yun yung area or the circumference na kailangan natin para mahanap yung ating magnetic field. In terms of magnetic field kasi, ang current, the stronger the current, the more magnetic field it generates. And the more magnetic field it generates, the farther the magnetic field reaches, the farthest one is always the one with the weakest amount of magnetic field, or like yung energy niya mas mababa. Because the way the magnetic field works around the current, the closer it is in the center, the stronger. So pinakamalayo, pinakamahinang magnetic field, sa pinakaloob or sa pinakamalapit is yung pinakamalakas na magnetic field. Okay, continuing, ang ating final formula sa ating Ampere's law is B is equal to the permeability of free space, which is the constant, 4 pi times 10 raised to the negative 7 times the current in the wire within unit of measurement is ampere or amps divided by 2 pi r, which is the radius from the wire in meters. So, ang ating tatandaan dito is ang magnetic field natin is written in Teslas. Teslas is, in our world, ang Teslas kasi is yung ating ginagamit to find out like how strong ba, kumbaga, ang isang magnetic field, which is na-apply siya sa real life equations or problems para makagawa tayo ng different machines at iba pa. So, in that logic, itutuloy natin ngayon sa ampere on ferromagnetic wires. So now let's focus on toroid and solenoids. So how does toroid and solenoid fit in Ampere's law? Well, to find that out, we need to look into what a toroid and solenoid is. So ano nga ba ang isang toroid at ano nga ba ang isang solenoid? Paano sila nagdi-differentiate? Ang isang toroid, so ito ang definition muna ng ating toroid. A toroid is a three-dimensional geometric shape that resembles a donut or a bagel. It is formed by taking a circular ring and rotating it around a central axis, creating a solid object with a hole in the middle. Toroids are commonly used in electrical engineering and physics as they can be used to create magnetic fields and store energy. So, ginagamit ang ating toroid magnetic field para mag-store ng energy at mag-create ng magnetic fields. Ang makikita natin sa picture natin is na ang ating current is dumadaloy through electrical wires or sa ating ferromagnetic wires. Then, the magnetic field that the current generates is inside the toroid, which is in a geometric shape within of a donut. So basically parang donut shape nga siya. Donut shape siya na isang object, and i-take into account natin dito sa ating formula for the toroid is yung number of loops. Kasi nga sabi natin kanina, the longer the wire is, the longer the wire and the more loops, the stronger the magnetic field, as well as the stronger the current. So our formula now becomes the magnetic field B is equal to the permeability times the number of loops times the current divided by 2 pi r, since we're now looking forward and we're looking into the number of magnetic fields generated in a toroid. So now we go to a solenoid. What is a solenoid? A solenoid is an electrical component that consists of a coil of wire wrapped around a cylindrical shape, such as a metal rod or plastic core. When an electric current passes through the wire, it creates a magnetic field around the solenoid. So, si solenoid daw, isang coil of wire pa din, which this time is naka-wrap around through a series of loops in one long line or in one long succession. So yun yung difference ng kanila. Si solenoid may ginagamit na different formula pero still uses the Ampere's law. Following the Ampere's law is what I'm trying to say. This time, si solenoid naman, wala na siyang divided by 2 pi r. So bakit nga ba wala siyang 2 pi r? Well, so the difference between a toroid and a solenoid, the reason is, sa isang toroid, si toroid kasi, meron siyang non-uniform magnetic field. At si solenoid naman is a uniform magnetic field. In which case, kay toroid, kasi, ang na-degenerate niyang magnetic field is inside the core, which is, sabi nga natin, donut shape. So, cylindrical, is basically cylindrical in a donut shape form. So, in that case, tutuloy naman natin kay solenoid, since ang current niya is nandun sa loob ng wire in a full succession, ang magnetic field na na-degenerate na is nasa labas ng core. So, with that being said, dahil nasa labas ang magnetic field natin, wala siyang 2 pi r. Diba? Then, kay toroid naman, since nasa loob, may 2 pi r siya. Pero, then again, we still follow the number of loops. Hindi natin sila matatanggal kasi the more number of loops we have, the stronger the magnetic field. Okay? So, again, I repeat, the difference between solenoid and toroid is the toroid has or generates a field inside the core, while a solenoid generates a field outside the core. Okay? Ang formula ni solenoid is equal to the magnetic field B equals to the permeability of free space times the number of loops times the current. Okay, solenoid, same but divided by 2 pi r. So sometimes we see symbols where we try to illustrate the direction of the magnetic field, where we sketch them as into the page and out of the page. So how do we know when it's going into and out of the page? Well, into the page, we use the symbol X, and for out of the page, we use the symbol dot, or just basically just a dot means out of the page, X just means into the page. That's it. Yung ginamit natin kanina right hand rule, ito ang curl right hand rule, tulad ng sabi natin is ito yung direction ng current ng flow, at ito yung direction ng ating magnetic field. Ngayon, meron ba tayong ginagamit na right hand rule, which is ganito ang itsura. Ganyan. Although magmukha ang baliw, kakagawa nito, mas nakakatulong ito para malaman natin ang points ng paghahanap ng direction in our magnetic field. Okay? So imagine conductor, may isa tayong conductor passing through a magnetic field. Okay? Sa isang magnetic field, nagpapasok tayo ng isang, let's say, one piece of metal or a tube. Natin isang tube or wire. Yung tube na yun, let's say, from bottom to top, ipapasok natin siya sa magnetic field, which is ngayon, ito yung motion ng ating conductor. Okay? Going up. Now, since alam na natin na going up ang ating conductor, ngayon natitignan naman natin ngayon is yung direction ng current. Okay? So, let's say merong magnet dito, may magnet din dito, at may nagkakos ng magnetic fields sa kanilang gitna. At itong mismong conductor ko, pinasok ko sa gitna nila, ang current is pakaliwa. Okay? Pakaliwa yung current. So, ngayon, ang itsura ng ating right hand rule is naka-point papalayo. Ang conductor is pataas, current is pakaliwa, ang ating magnetic field is ito. Dito siya. Itong finger na to. Ang ating magnetic field ngayon ay in this direction. Doon papunta ang magnetic field. Dito ang motion ng conductor pataas at pa-left yung current. Ganito yung itsura. At magbabari siya depende sa perspectives na ating kailangan hanapin. Tandaan natin na hindi siya magbabago. Ganito pa rin ang itsura niya. Ang pinagkaiba lang is yung mismong perspectives at kung paano natin siya titignan at babasahin. Basically, ganun ang general idea ng right-hand rule na yun.
So, application of magnetic field. Saan nga ba natin nagagamit itong mga magnetic fields na ito? Okay? Magnetic fields are really important in our everyday lives and they're used in a lot of different things. So, which of the following is an application of magnetic fields? So, first one is motors. Motors use magnetic fields to convert electrical energy into mechanical energy. When a current flows through a wire in the motor, it creates a magnetic field that interacts with other magnetic fields to produce motion. Motors are used in things like fans, washing machines, and even cars. Second one is speakers. Speakers use magnetic fields to convert electrical signals into sound. When an electrical signal is sent to the speaker, it causes a coil of wire to vibrate, which creates sound waves. The coil is surrounded by a magnet, which helps to create the magnetic fields needed for the speaker to work. Third one is the MIR machines. MIR machines use magnetic fields to create images inside of the body. When you're in an MIR machine, you're surrounded by a strong magnetic field. The magnetic field interacts with the hydrogen atoms in your body to create images that can help doctors to see things like broken bones or tumors. Which of the following is not an example of technology or device that uses magnetic fields? Credit card strips. The black strips on the back of your credit card contains a magnetic field. When you swipe your card through a card reader, magnetic fields interact with the reader to transfer information about your card, like your account number and expiration date. In conclusion, magnetic fields are used in a lot of different things, from motors to speakers to an MR machine, credit cards, even computers, and another thing, and washing machines. They're really important in our daily lives, and they're a really cool example of how physics can be applied in the real world.
Good day, my fellow STEM students. Marclusip Dalman here from Tab Archimedes. Now that we've watched crucial information and concepts regarding this topic, magnetic fields produced by currents, I think we are now ready to try some practice problems. So in answering these solving problems we're gonna do it in a systematical way using the Gresa technique, which is the given, required, equation, solution, and the answer. So let's get started. So we have here our first question. It is a simple question. So if you want to answer, just pause the video. So let's proceed. So find the magnetic flux density 1 cm from a straight wire carrying a current of 25 amperes. So the given in this problem is current, which is 25 ampere, and the R, or the distance, is 1 cm, and the required is the magnetic flux, or the B. So we have here our sheet formula. We're going to use the third equation. So let's proceed. So our equation is B is equal to permeability of free space times the current all over 2 pi times R. So the solution for this is we'll just simply substitute the values in the equation. So B is equal to 4 pi times 10 raised to negative 7 Tesla meter per ampere times 25 ampere all over 2 pi times 0.01 meter. So we're going to have B is equal to 5 times 10 raised to negative 4 Tesla. So the answer in this problem is the magnetic flux is 5 times 10 raised to negative 4 Tesla. So the second problem that we have here is this one. So if you want to answer this, just pause the video. So the hot and neutral wire supplying DC power to lighter commutator train carry 800 ampere and are separated by 75 centimeter. So what is the magnitude and the direction of force between 50 meters of these wires, and discuss the practical consequences of this force, if any. So the given in this problem is the current is equal to 800 ampere and the length is 50 meters and the distance is 75 centimeters. So the required is the magnitude and the direction of the force. So we have here our visualization. So for us to find the direction of the force acting on each of the wires, we will first apply the right hand rule 2 in both wires, in both current wires. So let us first apply the right hand rule 2 in this red wire, or the hot wire. So we have here the right hand rule 2 states that if the right hand thumb points in the direction of the current, the fingers will curl in the direction of the field. So basically, i-imagine natin na yung may hawak tayong wire dito, and yung thumb natin ay yung direction ng current, tapos yung 4 fingers natin ay yung direction ng magnetic field. So like this one. So kung i-apply natin dito sa red wire or the hot wire, so if we're going to apply that, makikita natin na yung hot wire is pointing siya sa right side. So our thumb should be pointing to the right direction. So, yung fingers natin is magka-curl as if na meron tayong hawak na pen. And yung pen na yun, ayun yung wire. Dapat magiging ganito yung itsura and nakapoint sa right side. Now, yung 4 fingers na, ayun yung direction ng magnetic field natin. So, yung tip ng fingers natin is nakapoint siya sa palm natin, which is, ang visualization done, ito. So, yung direction na yun, nag-go siya in a counterclockwise kapag tinignan natin siya from above. So, from above the wire or the current wire. So, yung ikot ng magnetic field na yun is counterclockwise. So, just like this one. So, kung mapapansin nyo, ito yung tip ng fingers natin is, it is going in the palm. So, the direction of the magnetic field is going into the page sa baba ng wire dito. So, may mga X yan dito. Mga X, may mga X. May mga X, may mga X, may mga X. Then, kung mapapansin natin, sa taas naman, sa taas ng wire natin is nagpo-point yung direction papunta sa atin. So, if that's the case, then the direction ng magnetic field sa taas ng wire natin, ng wire na to, is going towards us, so out of the page. So, meron tayong mga dots dyan. Now, using this, we can find the force acting on the neutral wire. The direction of the force acting on the neutral wire by applying the right hand rule 1. So, if we're going to apply the right hand rule 1, so right hand rule 1, ito yung direction ng magnetic field natin, ito yung direction ng current, and yung palm natin, kung saan nakatutok yung palm natin, ay yung direction ng force natin. So, kung mapapansin nyo, meron tayong mga dotted lines. So, apply natin yung right hand rule 1 dito sa neutral wire. So, makikita natin na yung neutral wire is pointing to the left. So, let us first point our thumb to the left. Kasi ayan yung current wire natin, dyan yung direction. And kung mapapansin nyo, itong dots na to, ayan yung direction ng magnetic field sa right hand rule 1. So, ito yun, yung 4 fingers natin. So, kapag out of the page, ibig sabihin, yung 4 fingers na to, dapat nakaturo siya sa face natin and palayo sa screen. So, if that's the case, dapat magiging ganito yung itsura. Nakaturo yung 4 fingers natin, papunta sa atin and palayo sa screen. Tapos yung thumb natin is nakapoint siya to the left based sa direction ng current wire. So, kung mapapansin natin, yung palm natin is nakapoint siya upward. So, yung palm natin ay yung direction ng force natin. Therefore, we can conclude that direction of the force acting on the neutral wire created by the magnetic field of the hot wire is pointing upward. So, the force acting on the neutral wire created by the hot wire. Now, para mahanap natin yung direction naman ng force acting on the hot wire, ang gagawin naman natin is i-apply natin yung right hand rule 2 naman sa neutral wire. So, i-apply na natin yung right hand rule 2 sa neutral wire para mahanap natin yung direction ng force acting on the hot wire. So, yung hand natin, dapat yung thumb natin nakaturo siya sa direction ng current. So, it should be pointing to the left side. And dapat yung fingers natin magkukulo siya as if may hawak tayong ball pen or pen. And yung pen na yun, ayun yung current wire natin. So, it should look like this. At pag ganito, pero pointing to the left. So, kung mapapansin nyo, yung tip naman ng fingers nyo is na nakaturo siya naman ulit sa palm below sa above ng wire. So, to further visualize, ganito, counterclockwise pa rin yung ikot. So, ito yung tip ng fingers natin. So, above the wire, the direction of the magnetic field is going into the page. So, may mga X tayo dyan. Mga X tayo dyan. And, sa below naman ng neutral wire, which is this one. So, mapapansin nyo na it points towards you. So, out of the page. So, meron tayong mga dots dito, below the neutral wire. Now, malalaman na natin yung direction ng force na nag-a-act sa hot wire by applying the right hand rule 1. So, if we're going to apply the right hand rule 1, so, ito yung hand natin. So, yung thumb, nakaturo siya dapat sa to the right. Tapos, kung mapapansin nyo, ito namang mga dots na to, nag-i-indicate yan na dapat yung magnetic field natin sa right hand rule 1 or yung 4 fingers natin is nakaturo sa face natin and away from the screen. So like this, like parang cobra. So ganito dapat yung itsura niyan. Nakaturo yung 4 fingers natin sa atin and yung thumb natin nakaturo sa right side. So kung mapapansin natin, yung palm natin is pointing downward. Therefore, the force acting on the hot wire created by the magnetic field of the neutral wire is going downward. So the force acting on the hot wire created by the neutral wire. So merong shorter way para malaman natin yung direction ng force acting on parallel current wires. So ang shortcut dun is kapag yung direction ng parallel current lines are opposite sa each other, kagaya nito, mapapansin nyo, this one is pointing to the left one and this is pointing to the right. So the first should be repelling, or they have an repulsive interaction. So with that being said, kapag itong line na to, ginawa natin siyang same direction dito sa hot wire, so yung magiging force niyan is nagkakaroon ng attraction. So that's the shorter analysis para malaman natin yung force na nag-a-act sa parallel current wires. So ginawa ko yung analysis by using the right hand rule 1 and right hand rule 2 para mas maintindihan natin kung ba't sila nagre-repel and ba't sila nag-a-attract. So let us now move on in answering this question or this problem. So for this problem, we're going to use this equation, the second one. So our equation is, so since itong parallel wires na to nagbi-build sila ng circuit, so yung ampere netong current wire na to is the same as sa ampere ng neutral wire. So kapag kinuha natin yung force neto is the same lang as sa force ng nag-a-act sa hot wire. So gagamitin lang natin is isa. So our equation is the force acting on the neutral wire created by the magnetic field of the hot wire is equal to current times the length of the wire times B, or the magnetic field, times sine theta. So hindi naman given yung angle, so let's assume that this is 90 degrees, so sine 90 degrees is equal to 1. So pwede naman natin, hindi na natin ilagay. So our equation is the force is equal to current times the length times the magnetic field. So since sa given natin is meron tayong r or distance, and sa equation na gagamitin natin is hindi given yung r or walang r na variable, we're going to substitute the formula of B so that we can have the variable r, because B is equal to permeability of free space times the current all over 2 pi r. So with that being said, we're going to substitute that for B. So we have now force is equal to the current times the length of the wire times permeability of free space times the current again all over 2 pi r. Now that we have two currents, so if we multiply that, we have I squared. So the force is equal to I squared times the length of the wire times the permeability of free space all over 2 pi r. So the solution is we're just going to substitute the given values so in the equation. So force is equal to 800 amperes squared times 50 meters times 4 pi times 10 raised to negative 7 Tesla meters per ampere all over 2 pi times 0.75 meters. So the force acting on the neutral wire created by the magnetic field of the hot wire is equal to 8.53 newtons. So the force is the magnitude of the force acting on both wires is 8.53 newtons, and the force are repelling to each other, or they have a repulsive attraction based sa ginawa nating analysis. So we have here our last solving problem. So if you want to give it a try by yourself, just pause the video. So let's proceed in answering this problem. So we have here the wire carrying 400 amperes to the motor of a commuter train feels an attractive force of 4 times 10 raised to negative 3 newtons per meter due to a parallel wire carrying 5 amperes to a headlight. So A, how far apart are the wires, and are the currents in the same direction? So the given for this problem is the current of the wire 1 or I1 is equal to 400 amperes and the current of the wire 2 I2 is equal to 5 amperes. And the force per length, this is for wire 1, is equal to 4 times 10 raised to negative 3 newtons per meter. So the required is the distance between the wires and direction of the currents. So we have here the visualization or the sketch. So given in the problem that the wire 1 or the wire that is carrying 400 amperes feels an attractive force of 4 times 10 raised to negative 3 newtons per meter. So it is stated that the force of wire 1 is attractive the force of wire 2. So based sa analysis natin from the previous problem, so if yung force ng parallel current wires are attractive or meron silang attraction sa isa't isa, ibig sabihin yung direction ng current wires are the same. So that's why makikita nyo yung direction ng current wire 1 is the same sa current wire 2. So hinahanap natin is yung distance between them. So this is the force of the wire 1 created by the magnetic field of the wire 2. So ginawa natin analysis in the previous problem. So we're going to use the equation force acting on wire 1 created by the magnetic field of wire 2 is equal to the current of wire 1 times the length of wire 1 times the magnetic field of wire 2 times sine theta. So ulit, hindi given yung angle. So let's assume na 90 degrees yun. So sine 90 degrees is equal to 1. So hindi na natin kailangan ilagay yan. So force is equal to current of wire 1 times times the length of wire 1 rather times the magnetic field of wire 2. So since problem natin is given yung isang current which is the current of wire 2, ang gagawin natin is substitute na naman natin yung formula ng magnetic field of wire 2 para makuha natin yung variable na current of wire 2. So with that, substitute na natin. So we have here force acting on wire 1 created by the magnetic field of wire 2 is equal to the current of wire 1 times the length of the wire 1 times permeability of free space times the current of wire 2 all over 2 pi r. So kung papansin nyo sa given natin is meron tayong force per length. So dito sa equation natin is meron tayong force at meron din tayong length. At saka yung force per length na to is for wire 1 to. So we can just put these two variables together so that we have this force per length which is equivalent to 4 times 10 raised to negative 3 newtons per meter. So itong two variables na to is will act as one as given. So force per length is equal to the current of wire 1 times permeability of free space times the current of wire 2 all over 2 pi r. So ang hinahanap sa equation sa problem na to rather is the distance between the two wires. So by just cross multiplying all the variables and isolating r for us to find its value. So we're going to have r is equal to the current of wire 1 times permeability of free space times the current of wire 2 all over 2 pi times the force per length of wire 1. So now that we have this equation, so the solution for this problem is we're just going to just simply put all the values in the equation. So we have r or the distance is equal to 400 amperes times 4 pi times 10 raised to negative 7 plus 10 meters per ampere times 5 amperes all over 2 pi times 4 times 10 raised to negative 3 newtons per meter. So the r or the distance is equal to 0.100 meters or 0.1 meter. So answer for this problem is the distance between the two wires is 0.100 meters and both wires have the same direction based sa ginawa nating visualization and analysis. So that will be all in solving problems with regards to this topic, magnetic fields produced by currents. So I hope na may mga natutunan kayo. Salamat.
So, a brief summary lang ng mga tinakal natin today. First one is magnetic force. Magnetic force is an attraction or repulsion that arises between electrically charged particles because of their motion. Magnets can either repel or attract due to its magnetic force. When pushing two magnets towards each other, you'll see that they push each other apart or snap together. Attraction or repulsion between the magnet is called by a magnetic field. So, kunyari, ito yung magnets. So, when you push, kunyari, pag pinush sila, minsan they push one another or they snap together. So, ang nagkakos nito is the magnetic fields. So, the invisible field surrounding the magnet is called the magnetic field. Imagine a bubble. Imagine kayo ng bubble dito sa, kunyari ito yung magnet. Kunyari may invisible bubble dito and yun ang electrical field. So, the closer you are to the magnet, the stronger the magnetic fields are. So, think of a magnet. So, kunyari magnet to, there's a north pole and there's a south pole. Pag nilapit mo si south pole sa isang north pole, mag-attract sila. If you pag pinut mo yung south pole at saka south pole, they will repel each other. So, ang ano na to is called the pole law. It's similar to the charge law. So, field lines start at the north pole, form loops, and at the end of the south pole. Field lines never cross, and their density indicates magnetic field strength. The tug-of-war analogy illustrates how magnets behave when pulled in the same or opposite direction. Sketching and interpreting magnetic field pattern is like making a map of a magnet invisible force field. Just like how a map shows you how to get from one place to another, a magnetic field map shows you how the magnet force flows around the magnet. Iron filings are used to measure the invisible force around magnets. When we sprinkle tiny piece of iron near them, they form lines that show the shape of the magnetic field, with the lines being thicker near the magnet ends and the force being strongest. This experiment helped us understand how magnets attract and repel each other, and it's a great way to learn about magnetism. Unit of measurement of ampere, or A, is the rate of which electrons flow past a point in a complete electrical circuit. DC flows in one direction only, while AC flows back and forth, similar to the difference between water flowing through a hose and air flowing from a fan. So, yung ibig sabihin daw nun is, yung DC is, nag-flow lang siya in one direction lang. While yung AC naman is, nagba-back and forth siya, or bumabalik siya. So, magnetic field is produced whenever an electrical charge is in motion. As current moves through a power line, it creates a magnetic field called an electromagnetic field. The strength of the EMF is proportional to the amount of electrical current passing through the power line and decreases as you move farther away. When a wire carries an electric current, it creates a magnetic field around the wire. The magnetic field can be visualized using magnetic field lines, and its strength depends on how much current is flowing through the wire. Magnetic fields have both direction and magnitude, resulting in a general relationship between current and field known as the Ampere's law. The Ampere's law is a special rule that explains how electrical currents creates magnetic fields, like invisible forces that can pull or push objects. It is like when a light switch turns on a light bulb and the electricity flows through the wires in the wall to the light bulb. It helps us understand how big magnetic fields are made by lots of electrical currents, like in a big machine that uses electricity, and help us design and make the machine works better. Ampere's law states that for any closed loop path, the sum of the lengths of the elements times the magnetic and the direction of the length element is equal to the permeability times the electrical current enclosed in the loop. This is a general formula which means it varies depending on the shape of the wire. So the right hand rule. The right hand rule is a hand mnemonic that physicists employ to assist them to recall the magnetic force direction. So, make an L with your right hand, your two fists. Ganyan siya. Okay? So, meron siya for loop wires, straight wires, and the solenoid wires. The first one is for straight wires. So, imagine this is a wire, and the current is going upward, so your thumb is going to be upward. Okay? You only use your right hand. That's why it's called right hand rule. So, upward. And kung paano nagka-curl yung fingers mo, dun papunta yung electric field. So, pag ganun siya. Like, pag-ganun. Okay? Second one is loophole. It's the loop wires. There is a right-hand rule for a current carrying loop which helps us remember the direction of the B field. The palm curves in the direction of the current in the loop. The thumb indicates the magnetic field direction. This direction is perpendicular to the loop. It's also the direction of the magnetic moment. Mu. A solenoid is a coil of wire with electrical current flowing through it, giving it north and south magnetic poles in the magnetic field. The fingers of your right hand wrap around the coil in the direction of the convention current, while your right thumb points in the direction of the north magnetic pole of the coil. Kunyari, pag ganun yung, susundan mo lang yung loop ng wire. Kunyari, papasok siya dito. So, pag ganun. So, ang north pole mo is pag ganun. Ang south pole is dito. If pag ganun naman siya, so, pag ganun, so, pupunta dito yung north pole and dito naman yung south pole. Okay? That's all. Guys, thank you for watching.